The reaction between zinc metal in silver nitrate solution is an example of a single replacement or single displacement reaction. You have the form where you have an element and a compound before the reaction arrow. So you're going to see if that element, if it's a metal, if it's reactive enough to replace the cation in the compound. If it's a halogen, then you want to see if that's higher up on the periodic table and therefore more reactive than the halogen that it's trying to replace. In this case, zinc is a metal, so we want to see if zinc is more reactive than silver. You'll get this activity series of metals on your reference sheet on your exam. Silver, you see, is at the bottom. So zinc is going to displace silver. So silver is going to precipitate from this reaction, and zinc is going to go into solution with nitrate. Now, zinc is a transition metal with a single charge. It's almost always 2 positive. And nitrate is a polyatomic anion with a 1 negative charge. Those charges will give you the ratios between these cations and anions. So you need 2 nitrates for every zinc cation. Let's balance this. You see that there's 2 nitrates on the product side and only 1 on the reactant side. All right, I was running out of room, so I rewrote this to give myself a little more space. And by the way, all nitrates are soluble, so we indicate that with AQ. All right, so as I was saying, there's 2 nitrates on the product side. There's only 1 on the reactant side. So we need a coefficient of 2 there. That's going to give us 2 silvers on the reactant side. So we're going to need to put a coefficient of 2 where we see silver on the product side. So here's your balance equation for this single replacement reaction between zinc in a solution of silver nitrate. Now, the truth is, these ionic compounds are dissociated in water. We'll get to that in another video when we go over ionic equations. And all single replacement reactions are also redox reactions. But we'll cover that as we do other problems.